Okay, in this video, we're going to finish the 3.1 notes, the weighted mean, and real quick, just mention a couple calculator and formula sheet things. So skip this example in the other video, the weighted mean. So it says it's used when all data are not represented equally, and there is a formula in the book, but I want to kind of come at this without the formula. So let's look at this example. It says a student's GPA, what is it if they receive the following grades? We had an A in stats, C in history, a B, and a C. So hopefully you know from high school that you get that GPA, 3 point whatever, based on an A is being worth 4 quality points, a C is 2, a B is 3, another B 3 points, and a C is 2. So that 4.0 scale. So if you just looked at this way, and this was just like high school grades, you would do this, add those all up. And I kind of had those in here. Let me get my calculator there. So you would add up those values. You have your 4, your 2, your 3, your 3, and your 2, and say, okay, a total of 14 points, and we would divide by 5 classes. So divide by 5, 2.8, and my average would be a 2.8. Well, it turns out that isn't quite the way this problem is going to work, and it has to do with these values over here. So these courses are weighted differently, so you don't have this in high school, but when you'll get to college, you will find this. A lot of classes are 3 credits, a lab class, and maybe a physics class might be 4 credits, so it's worth more. You spend more hours in class because you have a lab, and then generally it's going to affect your GPA more. And then aerobics might just be a class that doesn't meet as frequently, and it's only one what they call quality point or credit. And then also as you go to college, you pay by credit. So you might have the same number of classes as someone else, but be taking more credits and paying more. So how do we take this into account when we calculate our GPA? Well, we look at it kind of like we did with a frequency table, that instead of adding these up and just looking at this as 4 pieces of data, we're going to look at the weight. So I'm going to just list those instead of A, B, C. We have our data. We got a 4 for our A, a 2 for our C, a 3, another 3 for our other B, and another C. But then instead of a frequency, we just have something called a weight. So they have to tell us what the weights are. And we're just going to count these first 2 equally. But then that B in physics counts a little more, and the C in Spanish has a weight of 3 and the 1 credit. So then what we go ahead and do is we look at those weights kind of like we did frequency. And we say, okay, well, how many credits was I taking altogether? So I had 14 credits. And then we look at kind of how many points you earned. So if we had 4 or an A, but times a weight of 3. So we're going to multiply going across just like we did with frequencies. And we're going to say that was like 12 points. Here, 2 times 3, a C was worth 2, and that was a 3 credit class, so that got weighted as 3, and so on. So multiplying across, like I said, just like we did with data in a frequency table times the frequency, and 9, and finally a 2. So we get these values. So this 14 credits is our total weight, kind of like a frequency. And here's our total points. Add those up. Double check 24, 30, and 11 more, 41. So 41 points is kind of what they call those quality points or points for grades. And then our final answer would be, well, we need to get our X bar, or I guess in this case, actually, probably mu, because this was just our data, 41 divided by 14. And we're going to find out, instead of, before we had come up with 2.8, if I just added those numbers and divided by, I had 5 classes. Now I'm looking at this a little differently, and I'm looking at 41 points when I weight them, divided by 14. So the 14 was that total weight. And now I got a 2.92 or 2.9, I guess 2.92, let's go with 9. So that was 2.929. So lots of times you'll see GPAs reported, I guess usually to 3 or 2 decimal places, but we could go ahead and go to 3. So that is what that looks like. So you will see us look for and do a weighted mean or two. I'm going to just mention there is a formula in your book, and that is on page 115, and the PDF for that is 13. And the formula looks like this, and they just say for X bar, what you would do for a weighted mean is you would sum up all your X's. We took all our data values, that's what X is, times, instead of their frequency, their weight. So they just use W for weight. And you would divide by, well, you would just add up all the weights. So this is just, I'm just going to write that out. This is your data times how much each is weighted. And then down here, it's the sum of what they are calling the weights. And all we are saying is look at those weights and basically treat them like frequencies. Like a frequency. So that is really it for that. But we had a couple other things I want to point out. So if you did not have the luxury of getting this lesson live or you missed class, other things I wanted to look at real quick. First is the formula sheet. So you're going to find this in the folder labeled reference materials. And please, if you can find a way to print it for yourself or get a friend to print it for you, a hard copy, I think really is a great thing. So we're going to start, and we have started using the front side of this. So the front side is what we cover first term. And you're going to notice up in that top row actually is 3.1. So this top row is actually what we just covered, 3.1. Now you might want to kind of look across at it and see what information is there. This is what you have at your disposal anytime you're working on a book, on an assessment. You always have this. So the first one just says sample mean for a list of data. So just kind of knowing what this says to find the sample mean. So there's one thing it tells you. There's one of the two symbols for sample mean. It doesn't have the mu on here, but this just says you're going to sum the data, and then down here divide by the total number of data. So you can write on this, kind of start getting comfortable reading this formula sheet. The next one says, what do you do for a frequency distribution? And this is exactly what we did if we look back at the couple frequency distribution examples. And I'm just going to put this back in here. We went ahead and took our data value. Maybe it was the midpoint that we had to use if it was groups. Or back on the other side, we took our raw numbers that we had and we knew their frequencies and we multiplied them. And then we added that up. And that's what this says. So this is just a nice little summary formula way to say that. So add up, and this says take your data. So X is your data. So data times the frequency. And again, that big sigma just says sum. So we're going to sum all those up and then divide by, and on the bottom, the sum of the frequencies. We had to go back and remember, again, if you kind of glance back at, let me find the back of that. If you had to divide, we weren't going to just divide by, there were 6 scores, we divided by 25. The frequency was really important because we really got to think about kind of what this table is summarizing for us is really a list of 25 numbers. So we're going to divide by the sum of the frequencies. So you could label that on there. So this was the sum of the frequencies. So label it, do what you can with it. Depth of median, and I always forget that funky little formula has a term. So this isn't really the formula for the median. It tells you which particular term you want to go to. So again, we said if you had like a list of, I think I said 9 numbers, 9 plus 1 is 10, divided by 2 is 5. So it tells you go to the 5th term. So that's there if you like it, and you might choose not to use that and figure you're just going to count, and that's high. Perfectly fine. And mid-range. So mid-range is on here. I said we don't use mid-range a whole lot. So if you're thinking, it's just one more formula to remember, hey, it's on your formula sheet. So as long as you know H and L, high and low, you are good. So that was the formula sheet. And one other reminder or something to point out on the front of your notes, and I'm trying to find the front of mine from earlier today. And let's see, I think here they are. These are the actual front of your notes or from the previous video. I didn't necessarily point this out super well, but properties and uses on page 116, and I do have the PDF page now, that's 14, would be an important thing to look at in your book. And I just want to point this out because, again, since you don't have that physical textbook, I feel like people aren't as likely to kind of crack open that PDF file, but it's good too. And like I said, I'm not going to ask you to read the whole textbook, but this does reiterate some information, sometimes has some nice summaries. So this is on page 14 for the PDF, or 116, properties and uses of central tendency. So it just is a nice summary of the mean, the median, the mode, the mid-range, when to use them, why to use them, if they are affected by high or low data values, or basically if they're affected by those outliers or extremes. And that, like I said, is a key thing that we want to talk about. So please do look at those PDF pages. Really, this one, gives you a nice little summary up top with the definition and the symbol. Has that nice summary table. And the second page, we went over this, but also maybe has an illustration, a little easier to see, mean, median, mode. So that's on page 117 or PDF 15 for chapter 3. So please take a look, and that is it. Those notes will be loaded totally complete, and that formula sheet can be found in the reference folder. So please take a look.